they would have just canceled school, they would just try to do online.
I don't know about that. Some schools did and some schools didn't. So I don't know for sure.
I do have a question though. So
what?
if we were to have a bad weather day, would we still have to do online work, or would we just get the day off?
That's what we were just talking about. That's up to the school. Some schools like that did have too much snow to go into school, they did online only, and others didn't. I would say we here would probably just get a free snow day because we have a lot of days built in to the school year where we're not like in danger of losing funding or anything if we take a day off for snow. So I think we probably would have had a free day if there was a little bit more snow or it stuck around, but I don't know for sure. The superintendent decides that, not even Mr. Warner. Yeah, I don't know. That'd have been nice. Everybody close your Chromebooks. Close them up. Close them up. Close them up. Juan, close your Chromebook. Close your Chromebook. Appreciate it. Calm down, Terry. All right, so what we got today, we're continuing on with this section that we started on before we left for Christmas break. It's evidence for plate tectonics. So I'm just going to kind of recover this pretty quickly, and then y'all can go ahead and do the multiple choice assignment that's up there today. Yeah, multiple choice, fairly easy. Take your time on it and make sure you're looking through this to find any answers that you need. I will. It's not assigned right now, but I will assign the reading as soon as I get done talking. So there's only 3 pages on this evidence for plate tectonics kind of section of the book. The first page, they talk about learning from mid-ocean ridges. And so one of the things that kind of put us over the top from the theory of continental drift, where we kind of just thought they were floating around the continent, or floating around the globe, was that we discovered what was happening in the mid-ocean ridges. So we found these ridges in the middle of the ocean. We found out that the plates were spreading apart in those ridges, and that the rock that we found in the very center of the ridge was way younger than any other rock. And so it started out in the youngest at the very center of the ridge, and then just got older and older and older as we went towards the edge. And that told us about how the oceans and the oceanic plate were kind of growing from this central point in the ocean, this mid-ocean ridge. And that also helped explain why the oceanic plates were a lot younger. We don't see any really old rocks in the ocean. All of the old rocks exist on the continents, and all of the oceanic plate is very, very young. And so this helped us to take another step beyond what continental drift gave us and get further into plate tectonics and the actual scientific explanation for what was happening with the continents and how they were moving around. So this little map at the bottom just kind of shows you ages of the seafloor, and you can see that even the oldest stuff here, 180, 280 million years old, which is really not much. There's a little piece up here, some of the dark blue off towards the edges. But you don't even have rocks in the ocean that are anywhere close to like even 500 million years old, where on every single continent, you can find rocks that are like 3 billion years old at the least. And so there's got to be some explanation for why the ocean rocks are really, really young and the continental rocks are really, really old, because that doesn't make a lot of sense without an explanation. So we go further to the next page. If I can go all the way down here. The next page talks about the evidence for continental drift, which we went over in the previous assignment. They're going to be more simple things that are a little bit less scientific. Similar landforms are distributed across oceans. For example, mountain ranges or deserts that used to exist a long time ago look exactly the same, but they're separated by a huge ocean. So why do the Appalachian Mountains in North America, like Pennsylvania, Kentucky, those mountain ranges, why do they have the exact same age, the exact same rocks, and the exact same physical structure as the Scottish Highlands that are all the way across the Atlantic Ocean? Like they should be somewhat different if they formed at different times. Why would they be exactly the same? Same thing with glaciers. We have glacial evidence in areas that shouldn't have glaciers and that match up across vast distances of oceans. We have fossils of animals that as far as we understand, should not have been able to swim across an ocean. But yet we have fossils on Australia and in Europe and in North America. How did those animals get to these very far regions of the earth if they could only walk really slow and they couldn't swim and they couldn't survive in a saltwater ocean? These are all the things that led to continental drift, but aren't necessarily super scientific that they could really get the whole plate tectonics thing down. So they get into a couple more things of evidence for plate tectonics. The major things are going to be your mid-ocean ridge, the seafloor spreading, and then the onset of GPS systems. So instead of just thinking that the plates were moving, we can actually see them move now from space because we have GPS systems that are accurate enough to get down to like the centimeter scale. And so if all of North America moves a few centimeters a year, we can actually see it moving year after year after year and see which direction the plates are going. And then finally at the end here, the last thing that we needed to kind of take plate tectonics into a fully formed theory was why. Why are they moving? Like they're not just moving because they want to move, and it's not like they're just rolling downhill. There's got to be a reason. There's got to be something that drives these plates and makes them move. And so once we started to learn more about what's going on inside the Earth, we got the idea for how the plates are moving, which is essentially these two things, ridge push and slab pull, which is a way that gravity is kind of pulling on the plates as they get recycled and as they get created new stuff in the mid-ocean ridges. And then the other thing is going to be convection cycles, which they don't have highlighted, but they're right up here. As hot stuff goes from near the core of the Earth and comes up towards the surface, and then cold stuff sinks back down, you get these convection cycles, which can kind of drag the continents along the top as they move around. And so those are our three different things, ridge push, slab pull, and then your convection cycles that help drive motion. So that's what we got. That should go through most of the answers, I think, for today. If you have any extra questions, I'm here to help you out. Like, I will help you answer the questions. Everybody should get a pretty decent grade on this. So take your time, work through it. I will assign the reading right now, and if you have any questions, let me know.